And technically this is called the Economies of Backhaul. I'm not sure if it wasn't supposed to be the economics of backhaul, but really what we're going to talk about is the challenges. And one of my favorite stories relates to the iPhone launch. And I don't know if you remember, 2008 seems a long time ago now, when the iPhone first launched in Palo Alto in Silicon Valley and took off like a rocket, the local wireless provider rapidly ramped up the RAN and gave lots of new radio access and wireless, and performance was terrible. And so they decided to put in T1s to connect the base stations. And then that still didn't give to a good performance. And it took them nearly 3 years to get up to gigabit Ethernet to connect all base stations. And really the important point is, we've been talking about all the small cell capacity, and people have been talking about the backhaul connectivity, which is an obvious one. But if you don't balance the throughput that you have on the backhaul, and the economics of the backhaul is turning out to be a more major expenditure than the RAN. And I actually worked with a couple of companies to encourage operators to increase their expenditure on the backhaul. And we've seen it go up from about 17.5% of total cost of operations to about 20%. And the good news is operators are now quarterly doing planning to upgrade the backhaul and mesh it with the wireless access. So it has to be part of the traffic planning. And really, as JDSU mentioned, it really is an important part of customer satisfaction. How many of you have had great bars with access to Wi-Fi and no throughput to the internet? That's a Wi-Fi backhaul problem. All of these networks have to balance their backhaul connectivity. So I'm going to ask our speakers to talk about their experiences and what are the challenges and new technologies that we have to make sure that we get adequate throughput at a reasonable cost. So let me first say that we have three very good speakers. We have Michael Freiberger, Principal Engineer with Verizon Wireless. Time to give Verizon a little chance to talk. Amit Khetawat, who's the Director of Products for AOptix. And Solyman Ashrafi, who is an investor, managing partner with NexGen Partners, but he also was one of the people at Metro PCS, and so he's looking at some very interesting new technologies in the areas of the access and backhaul. So with that, let me ask them to introduce themselves. Let me start on the far end, and if you can briefly introduce yourself, and then I'll ask Verizon to give a little bit of an overview of the challenges, and then ask AOptix to talk about some of the new solutions, and then ask Solyman to talk about some of the innovation we've seen.
Great, thank you. So my name is Mike Freiberger. I've been with Verizon for 20 years in the wireline side of the business. Obviously, we have a bit of fiber out there that we like to use for the mobile backhaul.
Solyman Ashrafi, I'm the managing partner at NexGen Partners. It's a stealth private equity firm. After selling Metro PCS to T-Mobile, we decided, the CEO, Roger Lindquist, myself, and a few others, we decided to launch a private equity firm and invest in technology companies. And what we found by talking to tier 1 operators and other operators in Europe is that they're not able to differentiate themselves based on applications. So what they want to do is that they want to use their existing assets and differentiate themselves. So that's why our investment thesis is entirely based on access. And we're going to disrupt the broadband access, whether it is fiber or RF backhaul or front haul or wireline. We are going after disrupting the broadband access.
My name is Amit Khetawat. I'm the Director of Product at AOptix. AOptix is a technology firm based in Silicon Valley, California. And our heritage is we have a very strong defense heritage. In the first 10 years, we built a network in the sky, if you will, basically connecting aircraft to aircraft and doing aircraft to ground communication, transferring about 80 gigs of data over 200 kilometers. And we use basically optical technology to accomplish that. And since 2010, some of the tier 1 carriers approached us. And there were, as Sue said, there were a lot of challenges in their backhaul networks. And they basically worked with us to commercialize some of their advanced defense technology for our backhaul applications.
So let me just ask Verizon to briefly outline kick off the discussion?
Briefly, yes, very briefly. So I'd like to start with a story by a gentleman from Union Wireless. So last year he was discussing how they provide services in Wyoming, and they provided a tower for Verizon to Verizon specifications on top of a mountain. What's interesting about that is that the Verizon specification is for a 75-foot tower on a mountain. You don't need a 75-foot tower on a mountain. So the question is that Verizon being arrogant because we push that standard? No. The answer is that Verizon establishes standards for deployment and tries to minimize the number of permutations so that a technician who normally works in Florida, when there's this small storm that moves into Manhattan called Sandy, can come up and restore a network and recognize what he's looking at or she's looking at. So you have to balance the previous speaker who says you can do all these different things. You can use fiber, you can use radio. Heck, I'd use 2 cans and string if it would carry the wireless backhaul at a cost-effective point and meet the service requirements. However, you have to balance that with, if you get into too many permutations, when you actually want to maintain and deliver quality service, how do you recognize it when you're standing in front of it? The second thing is that not all services used for front haul, mid haul, back haul, these different permutations are created equally. One thing that if anybody in the room heard of something called RTP or RTCP, or these acronyms, how about VoLTE? Yeah, okay, so a few hands recognize VoLTE. Well, these are all protocols and things that require great sensitivity to latency, jitter, as the previous speaker mentioned. But the question is, when you're buying that service or providing it for yourself, you have to be able to determine in real time what is the actual performance of that jitter or latency, so that you can eliminate that as a potential problem when you're troubleshooting your VoLTE or even video over LTE kinds of connections. So those are a couple of
Practical concerns and performance concerns. So AOptix has some cool new technology, and you're going to be able to translate this to the practical requirements of the network.
Yeah, I think great points there, Michael. I think the key word, I think most of the carriers in the US, the approach is fiber first. And you ask them why. So there are key performance, KPIs, capacity. Obviously, that's the #1 criteria driving for the fiber first approach. The second is latency. So if there is going to be a technology that is an alternative to fiber, it must offer similar characteristics. And so at AOptix, what we have developed is what is called a composite optical RF technology that takes what we developed with defense, the laser part of the optical pieces, combines that with the E-band 70-80 gigahertz to give fiber equivalent performance. Basically, it's the virtual fiber without requiring laying out physical fiber, and we can certainly do meet the characteristics of fiber, if not better. And the reason I say if not better is latency. The technology we use, as you know, we use free space optics, and light when it travels through air is slightly faster than light when it travels through the fiberglass medium. So from a latency perspective, we can simply meet those challenges. And capacity, our first product offers 2 gig, and it scales all the way up to 10 gig. Certainly, we anticipate the demand for the future needs, and I think we can meet those.
What about practical installation? Is it easy for a craft person to install?
Yeah, great question. And in fact, we have real life experience. One of our carriers did a trial where they were simulating disaster recovery. And so the situation was we shipped them the equipment and no training whatsoever. And basically the drill was they would take the equipment, decrate it, install it on the pole, what they call for disaster recovery. It's called cell-on-light trucks, which simulates like a tower down case. You roll out a truck there. And these guys from the carrier, they took the equipment, mounted it, And what we have is a technology called point acquire and track. It's the software which can be installed on tablets, which basically fully automates the process. All they have to do is mount it on a physical pole, hoist it up, and the two ends of the equipment automatically find each other in minutes. So we've completely made it idiot-proof, so to speak.
Point the lasers to each other and they line up.
Well, yeah, automatically they'll find each other and line up.
Cool. So Solyman, how are you going to disrupt this access market and yet be practical enough for the to meet the carrier requirements?
Yes. So we have been investing in some cool technologies ourselves in the stealth mode. What they are is, if you look at the whole landscape of telecom, is based on QAM modulation, and you go to higher order modulation, so you get higher capacities. What we have found there are some other orthogonal functions that offer eigenchannels, so to speak, and you can actually fit them within the fixed band. So you can create a layer of, if you look at the QAM modulation, it's like a two-story building sitting on a frequency real estate. What we are able to do is to create a high-rise building over that frequency real estate. So that is a temporal approach, but then we also have a technique to create what we call an electromagnetic vortex. It's an electromagnetic tornado that has certain helicities, and these helicities produce eigenchannels that you can multiplex through individual frequencies. So we have demonstrated this thing in RF, as well as in fiber, as well as in free space optics. So what we intend to do is to totally disrupt the broadband access to some new technologies that can give you 10x and in some cases 100x improvement. In the fiber case, we are able to multiplex 24 helicities with 42 wavelengths. That would give you 1,000x improvement, 1,008x improvement.
Yeah, I think everyone agrees if fiber is there, this is the preferred choice. One of my favorite stories about AT&T about 3 years ago, they said that they used, about 3 years ago, AT&T said that they used to deploy fiber for their UVerse network, just like Verizon does for Fios, or used to do for Fios. And they'd stopped that because the density wasn't great enough, they'd reached all the near neighborhoods. But then they restarted deploying fiber for mobile backhaul and adding UVerse as the customers wherever they were deploying it for mobile backhaul. So mobile backhaul is now the baseload traffic for the expansion of the US fiber network. So it's kind of a reversal. Mike, maybe you have some comments on what would it take for these new technologies to make it into the carrier class world?
So I think an interesting discussion is the scale of that, because I think scale is going to be the fundamental parameter there. Let's, for the sake of argument, say there's 30,000 macro towers in the network today. The expectation that with the fill-in that's going to happen, that is going to be more like 300,000. So think about 300,000 new access points in the network. It's an order of magnitude potentially higher. So when you start looking at that scale, things become very clear, because things like repeatability, simplicity, cost, of course, and maintainability. Because when you start looking at a network that large, not just from the radio side, the LTE side, radio side, but just the backhaul complexity, that's a very large and complex network.
It's the total cost of operations over the life of the infrastructure. So, is AOptix in trials with some of this equipment?
Yeah, absolutely. We are in trials with top-tier carriers in the U.S. as well as outside the U.S. But I just wanted to take a minute to address what Michael mentioned about scale. I totally agree with that. Any alternative, fiber is scalable, but it takes slow to roll out. It takes a while to lay out. If you think of an alternative technology, wireless transport, it must be scalable. So what does it mean? As he said, it must be able to deploy rapidly without requiring skilled technicians at each locations. And as I said, one of our key technology innovations, the PAT can help you achieve that. Second thing, you talked about maintenance. You know, you want a network, but you build it, forget it. You don't have to roll out trucks, go fix, oh, my microwave moved. You don't want that kind of issues. So what we have is technology called as active beam steering, that once you've aligned it, it automatically tracks. So even if the tower moves or twists, the far end will be able to detect it and move with the tower. So that minimizes your need for rolling out trucks. So I think the technology we have built into this product certainly can achieve, as Michael was saying, the scales desired for future networks.
So what are the challenges? You're solving the problem, Solyman, of the actual ability to share capacity and get a lot more bandwidth out of existing or new multiplexing techniques.
Yes. So what we are looking for is to use the existing infrastructure, whether it is backhaul or fiber or even copper. We do have a technology where if you were to put two modems on both sides of copper, you can almost convert the performance of copper to that of fiber. Now, how could that happen? It's because you are able to reuse the bandwidth multiple times. And if that can be done in the industry, you're totally disrupting the existing. You have sunk investments, which is called copper. So you can convert copper to gold, fiber, what I call backhaul gold.
Convert copper to gold.
Right.
Do we have any questions for our panelists? We've got some very innovative people here. Question over here? No? Just speak loud.
Can you hear me?
Oh, she's coming.
There's been some articles in EE Times and things like that about reusing the same things like you're describing. I'm just curious, is it nonlinear? Is it, we get pretty high now with the DSL, the newer versions and shorter lanes. You're not saying you can go through the switch and do that, are you? In order to get this? Or is it going to be just a copper link, fiber that you improve it, or could you elaborate a little bit on that?
No, so this is not a VDSL 2+ technology. This is not to, densify the twisted pair. It is really to take new eigenmodes and insert it into I and the Q of the QAM modulation and reuse the same bandwidth multiple times. When you do that, and of course there are physical limits of how many of these you can stack on top of one another in the modem, and the limit is controlled by the jitter in the oscillator. But if you can have stable oscillators and do that, you can almost convert the performance of copper to that of fiber. Now this is very disruptive because that's a sunk investment. You are in wireline business, you have them, right? So imagine that you would, like what some of the carriers are doing is that they don't see the light at the end of the tunnel, and they are auctioning or selling all of their wireline assets. And if you can convert that asset to the performance of fiber, there's no need to do that. You can leverage it. So these are the things that they would like to disrupt in the market. It's very different than DSL.
Any other questions, comments? Sure. Over here.
So you were mentioning the turning copper into gold. Does it matter the condition of that copper? I mean, some of the stuff that you guys have got is probably, several decades old. And I'm just wondering if that's a limitation at all.
It does, but I mean, we do have pilot channels where we would understand the impulse response of the channel, and we can correct for it either through MIMO and reduce crosstalks that are produced because of the channel impairments. But again, the way we as a private equity approach the problems is that we don't care what the medium is. We want to leverage the existing assets. whether it's wireless, and we have demonstrated this thing in both backhaul as well as free space optics, as well as fiber and copper.
Just to talk about really bad copper loops, for those of you that are not familiar, I was at Broadband World Forum and I learned for the first time about a technology that's now standardized as G.fast. How many people in this room have heard of G.fast? You don't count. If you haven't looked at G.fast, it's really cool and it works out with the worst copper loops. Bell Labs was giving a demo last week and they had to go on the eBay to go and find some 1920s type 2-wire pair with really bad insulation in order to test it. But there's now chipsets coming from Alcatel-Lucent, a little Israeli company called Scipio, that take the worst copper pair only for 250 meters. It's limited to that, but they essentially extend the fiber termination and create a virtual DSLAM. And the really cool thing is it takes reverse power from the pram. So in other words, the terminating point can provide the power source because the fiber doesn't have any power. So it's going to really help the crossing the road problem where you have a copper termination, as well as the kind of free space optics solution. The cool thing about free space optics, I guess, is you've got waveforms meeting waveforms. And it would really, my fantasy is that we one day do this all analog and regenerate analog signals instead of digital, so that you can have coherent waveforms or whatever you call them, over the air, over the fiber, and all the way to the other end over the wireless. So we ain't seen nothing yet on new technologies. But let me ask all the speakers to just give one last comment on what they'd like you to leave remembering about backhaul.
Yeah, I guess so. I think the need for fiber, we all recognize. The comment would be that fiber is not going to be ubiquitous. There will be several situations where fibers just cannot be trenched. You won't have fiber. Or there are conditions where carriers want to minimize their OpEx costs by not leasing from a competitive fiber operator. So for those conditions, you need a highly scalable wireless alternative. AOptix offers that using our Telemax core technology. So I highly encourage you guys to come to our booth where we can provide additional details.
Well, I would say that our multiple access technologies have evolved from GSM to wideband CDMA all the way to LTE, but our modulation part of our telecom is probably over 5 decades old, over 50 years old. We are still using the same QAM modulation based on sinusoidal orthogonal functions, where the whole world has evolved into better orthogonal functions that have better characteristics, and it has not been leveraged. So what we believe is that you have to go fundamentally to the physical layer and disrupt the modulation. It's time to do that because multiple access has evolved, but the modulation part has not. So that's what we plan to do.
Yeah, maybe to that point, maybe we haven't needed to until now. So yeah, that's right. So I'd like to leave